one here where basically we're using the mean and the standard deviation to kind of talk about data, right? So when you have, in this case, several players that we're comparing, these are their scores, right? So you could put like Anna into L1 and then Patrice into L2 like that. I won't do them all, don't worry about it. So 36, 39, 36 again, 38, 35, 37. Anyway, so you put them all in different columns. And so let's say you want to you want to find a range mean standard deviation for Anna, right? You just go stat, calculate, one variable stats, and just feed it L1. And then it will take everything that's in L1 and figure that out. I'll show you the key shortly, but the mean is 36.7 points. By the way, we always do decimals when it comes to mean, standard deviation, and all of that. It's okay to have decimals when it comes to statistics, even if it's like number of cases, because it's a measurement tool. We measure how many we have on average. Yes?
Did you sort it out?
I did not sort it because you don't need to sort it unless you want to make a line plot or you want to find the mode, right? I did tell you to sort it. It doesn't hurt to sort it, but this will do it with or without sorting it, okay? That's a good observation. Standard deviation, 5.88, okay? And I will say, as is, standard deviation doesn't help you much. Once you start comparing it to others, that's when it matters, right? So how do you find your range again? Range is always max, take away min, right? So if you go down the page, you have your max and min. So if you go 45 minus 27, you will get the 18, okay? 18 is the range here for this player. So what does that mean? That from the lowest score, the difference between the lowest and the highest score is 18 points difference, okay? So for the first player, nothing changes a whole, like really there. We just collect the information. If you want to do this again, stat, calc, enter, and now I will feed it L2. I'll say, hey, go to L2 and take those numbers. You run this again. You get 36.4 is your mean, and your standard deviation is 1.50, right? The 6 bumps that to a 10, which bumps this to a 5. So 1.58. You can tell that the standard deviation is significantly lower, which means that this player has more consistent scores. My scores are going to be closer to the mean on average, okay? And what about the range? We would expect, if everything is closer to the mean, you would expect that the range is also smaller, okay? So if we actually do the math here, 39 minus 34, you only have a range of 5, okay? So right like this, you should see the correlation there, okay? And if we do that for all of them, right, naturally would have typed Morgan into L3, the scores for Page into L4, and so forth. This is what you end up getting if you fill all of that out, okay? So this is already the filled out form. So if you compare the 5 players, you should notice that when it comes to the range that Morgan has the greatest range. Okay, Morgan, like some really bad days, some really, really good days, right? That's what that usually indicates. Look at the scores a little bit. Morgan has the highest score, I believe, of all. I think it's the highest of all. 48 is the highest ever. So Morgan has the highest score, but also has the lowest score in the whole set, like among all players. So has done really, really well, but also not done so well on other times. So that's why your range is also that big, okay? So if you think of Morgan, the range is like spread out. Like the difference between the high and the low is 29. Look at the standard deviation. If you compare all the other players, Morgan has the highest standard deviation, which means that, right, the average, like the points are not necessarily around the mean. They're not clustering around. They're actually, on average, farther away from the average, okay? So that's something that I want you to observe. And who has the lowest range? Paige has the lowest range and also the lowest standard deviation. And today I'm going to show you how to calculate the standard deviation by hand, okay? Not using your calculator. We're actually going to go through the process of doing that by hand, okay? Because and some of you might need it later on in college or university, so I do want to do that, okay? And now I can ask you other questions, like which player would be considered most consistent? Which one would be least consistent? Explain how you know. This is huge. This is where you get your marks, guys. Explaining how you know that. I would expect you to know that most consistent means what? The lowest standard deviation. That player is most consistent, right? So, Paige, so you would start something like this. Paige is most consistent, so you're making that point. How do you know that? We know this because she has the lowest standard deviation. Boom, you get the full mark there in my books, because you're saying who's the lowest and why, okay? And then the range is also the lowest, that you can make a strong case there. Morgan is the least consistent player, since the standard deviation is the highest, and the range is also the highest, right? So that's something that I would be looking for. When I say use statistical terms, that's what I would want you to draw attention to. The player with the highest average, you know, if I go back to A, I think I would like you to always write down like what the standard deviation actually is. Like write down the number maybe, just to make it even stronger. B, identify the player with the greatest average, which you consider her to be the best player. Okay? So the highest average, the highest mean is Anna. Let's look at her results. We got to dig deeper, right? So Anna has the highest average of all of them. But look at her range or standard deviation compared to all the other ones. She's basically, this is the least consistent. She'd be the second least, right? Like second lowest in terms of consistency. So just having a high average does not necessarily mean you're the best player. That's basically what we're trying to say here. We want consistency. Like if you have a hockey player or a basketball player that shines sometimes, like during the regular season, just crushes it, right? But then playoffs come along and it's like up and down, up and down. You can't rely on that player. Even if you did really, really well overall, look at my average, look at look at how many points that player scored. If you are not consistent, sometimes it actually isn't necessarily a good thing. Having a high average, of course, is good, but that alone is not enough. Okay, so remember, standard deviation, you dig deeper. Okay, you're doing a deep search, right? Not just on the surface. Okay, so Anna has the highest. She would not be considered the best player. She would not necessarily be considered the best player, since her standard deviation is quite high. Okay, Patrice has an average that is very close to Anna's, yet she also has a lower standard deviation. Okay, so what am I trying to say here? If you combine the two, Patrice is not the highest average, but is really close to the highest, and has a standard deviation that is not too bad compared to all the other ones. So if you combine the average and the standard deviation, Patrice is probably a good pick. okay, because has quite a bit of consistency, and the average is quite high. So that's kind of like the combination, the sweet spot there. Which player has the potential to score the least on any given game? Which one has the potential to score most on any given name? Explain. So least and highest is both Morgan. Okay, Morgan, since she has the lowest score of 19, and Morgan also has the potential to do the highest because her highest score was 48. Okay, so that's something that you should be able to answer. Let's move on to page 11. 10 is blank, right? Is yours blank on 10 or no? Yeah. Okay, let's go to 11, test scores. I hope the math part you guys are doing fine with. Okay. So you've got 2 unit tests, right? 2 geography tests that were given by the same teacher to the same class and the same semester. Okay. So here are the results. I would say you should at least try to follow or try to copy if you can. But you put the first unit test into L1, the second one to L2. Their average is exactly the same. But let's dive deeper. Let's look at the standard deviation. Test 1 has a much lower standard deviation than test 2, right? So this one was more consistent. This one is closer to your mean. The data points are closer to the mean. So you got to start thinking like the graph. If you were to graph both of these on the same grid, okay, and this is your average. The average is, the mean is the same for both. This class would be more spread out. So it's a flatter curve. And the first unit test is going to be a steeper curve because most of our data points are here where the average is. So remember, it's like an air balloon or a water balloon. If you were to squeeze in the sides and say, hey, most of you are closer to the mean, then the curve goes steeper, okay? It like rises up. Whereas if you spread it, if you pull the tails, right, and then it's going to be a shallower, flatter curve. Look at the median and the modes. They're exactly the same for both of them. I don't know if you guys, yeah, I did ask you to do that. And then here's your expert analysis, right? So now you're like going to talk about that. Both tests have the same overall average, so talk about the mean for sure. If one of them had a higher mean than the other, you would say in general, unit test 1, if that had the higher average, you would say they on average are doing better. This could possibly indicate that students perform similarly. However, when we look at the standard deviation, right, when we look at the standard deviation, so we talked about the mean, now we're talking about the standard deviation, we can clearly tell that students' scores were a lot closer to the mean, right, a lot closer to the mean in test 1. How do you know that? Because they have the lower standard deviation. Test 2 has a much greater standard deviation, which indicates that the scores are dispersed or spread out. Okay, I will tell you this honestly, on a test, you don't have to talk about both. You could have just picked test 1 and say average is greater or the same or lower, whatever the case may be. Talk about what that means. In this case, it would be if the average is higher, you would say generally they do better. And then talk about the standard deviation for test 1 and tell me what that means. You don't have to analyze both tests, right? You just talk about the one that you want to go with. So that's that. Let's go to page 12. And I asked you to fill out these 2 boxes here based on every city, right? And then you also do every year. Now, let me see here. I will check up with. I'm just going to show you the answers, and so for when it comes to the averages for 1996 is this, 1998 and 2000, right? You've got the different averages, and you can clearly tell that housing prices have been going up steadily. Standard deviation, 32,000, 35,000, 33,000, right? So if I asked you to analyze this, talk about the mean, right? When it comes to the mean, what can we tell? That the year 2000 has the highest average housing prices, right? So that means that houses are costing, right? They're the highest cost in the year 2000. So you talk about that. And if you go by the standard deviation, we can tell that you can either pick the highest, right? So in 1998, the price was most spread out or most inconsistent. You can talk about that because it has the highest standard deviation. Or you can pick 1996, saying 1996 was the most consistent in terms of pricing because it had the lowest standard deviation, right? So those are the two. The mean and the standard deviation is something that I would be looking for, okay? If you look at, we also did the other one by city. I don't know, some of you didn't get to it. But when it comes to, if you were to do this by city, right, you put this in L1, L2, L3, L4, there's 11 cities, right? And you can tell that St. John's out of all the cities has the lowest standard deviation, which means that that's the most affordable city in this particular time frame across the 3 years, right? And when you look at the standard deviation, I would pick, for example, I'd pick the lowest standard deviation, which is this one right here. That's Regina, right? You can talk about the fact that Regina, most house prices are closer to the mean. They're closer to that average that you're looking for. And then you could also pick the highest. Which one has the highest standard deviation? If you look at these numbers, it is Yellowknife, right? Yellowknife has the most inconsistency when it comes to pricing, which means that the average house prices are going to vary greatly from this, okay? I sound like a broken record, right? Yeah, I do. Anyways, so I hope that helps you. Let's write this down here so you have something to analyze the results in A. So I will say that the highest average occurred in the year 2000. Okay, this is dated, but the skill still stays the same. Due to the highest mean. Okay? And then I could talk about, I look at my results. The year 1996 shows the most consistent housing prices due to the lowest standard deviation. Okay? So keywords that I'm going to highlight: the highest average occurred in 2000. I know this because of the highest mean. And 1996 showed the most consistent housing prices because of the lowest standard deviation. Okay. I encourage you to expand, use your own words, use diagrams, use whatever you need to do, okay, to make your point. All right, I'm gonna stop there.